Welcome everyone. My name is John Rodriguez and I work on the Cache Android team at Square. Let's get started. So on Cache Android at Square, we move pretty fast and we expect our tools to help us move fast. For example, almost a year ago, we held the Kotlin World Tour at the Kitchener-Waterloo office in Canada, as well as the San Francisco and Melbourne offices, showing the company why we think Kotlin is an investment worth our time since it helps us iterate faster. This was a follow-up to our blog post excuse me, in May of 2017, where we announced a commitment to Kotlin at Square. Parallel to this, our team size have grown pretty rapidly. The Android team has grown from 3 to 11 in less than a year, and we're constantly thinking about how to keep our velocity and delivery up to our expectations. Today, I'll be speaking about one of the efforts we've been working on. Say you're working on the next hot feature. You get your hands on the Figma link and are eager to start coding. As any good Android developer, you probably start by creating a new XML layout file like so. From there, you might use the layout preview pane in Android Studio to take a quick look at how development is going. Here's how it would ideally look. But once your view iterates past a Hello World example, here's how it usually winds up looking. So now in order to view your work, you have to build the app and install it on a device or an emulator. This takes a while because Gradle. Sorry, Ruse. But seriously, the full Android build toolchain is very complex. Assets, resources, any transitive Android library manifests have to be processed and linked through APKs daemon, and ultimately packaged into their binary format in your APK. Java and Kotlin source files have to be compiled first into class files, and then shrunk, and then desugared, and dexed all in one step by R8. Apps still using the old support libraries will have to be jetified at this time as well. Finally, your app has to be packaged and installed onto an actual device or emulator. While ADB and emulators have improved over recent months and applied changes promises to improve on its predecessor Instant Run, the odds are this is taking a non-trivial amount of time in your builds. On Cache Android, our builds take an average of about 4 minutes, even after enabling the latest flags introduced in the Kotlin Gradle plugin. And this includes things like compile avoidance, incremental annotation processing, and caps. We've enabled all those flags. Once this is done, you can finally load it onto a device and emulator, but now the hunt to find the screen that you want to test begins. Maybe your app flow is server-driven, maybe it's behind a feature flag, maybe staging is down. And ultimately it's preventing you from getting to the screen that you want to view. There's a lot of burden overhead to just testing a screen that may not necessarily be your launch screen. By now I think you see my point. This scales really poorly as your app features grow and screens become more complex. Overall, iterating UI work on Android is challenging because it requires an app build to test. The graph that you see on the screen was taken from PY, who on the Square Point of Sale app, they wanted to figure out how many screens exist in their app and all the transitions potentially between all those screens. This is the graph that resulted. So now imagine if you're trying to iterate fast and launch a new screen, and you have to make sure that receipts are enabled, tipping is enabled, and all these this permutation of settings in order to ultimately find that screen. You spend more time doing that than actually iterating on your UI. This problem is not unique to the Cache team. Android developers around the world face this burden. Until now. In a blog post coming in the next 2 weeks, we're introducing a new open source project that I've been working on with Jesse Wilson. Its codename is Paparazzi, and it's a library written 100% in Kotlin to help accelerate Android UI development. Paparazzi started as a Hack Week project back in March. We started by digging around in the AOSP sources to learn more about how the layout preview feature in Android Studio works. Pro tip, if you want to understand the internals of Android Studio better, you can launch the IDE and edit the custom VM options in that help menu. Add this line to enable your IDE to launch when you have to restart in a debug server mode. And then from a second separate IDE process, you can add a remote attach run configuration. This will allow you to attach one IDE's debug session to the other IDE, and then you can introspect your behaviors in that latter IDE in order to understand how Android Studio internals work. It was helpful for understanding how layout preview worked, of course, but I've also been finding this extremely useful and can help the community help troubleshoot known issues in Android Studio, which are really hard to debug. Anyway, after digging around in the source for a bit, in good old hacking spirit, we copied some of the plugin jars out of Android Studio into our project workspace and started playing with the APIs. With a bit of refactoring, we were able to extract the core bits of the layout rendering library and borrowed some ideas from the Android Gradle plugin so that we can run the rendering pipeline on a pure JVM instead of building and installing the app to a device or emulator. Instead of the usual build times, Paparazzi takes a matter of seconds. As always, your mileage may vary. Now we still need to run some bits of the Android toolchain, but rather than running through this entire toolchain graph, as a JUnit test dependency, we're able to reduce it to only the bits that are necessary to compile the layout resources and populate our UI with view model data. So let's start with a simple example. Simple layout has 3 resource references to a color drawable, image drawable, a bitmap drawable, and another color drawable. Using Paparazzi, you would go to your dependencies block and add a direct dependency on it. In this case, it wouldn't be the project dependency, it'd be an external binary dependency on Maven Central. Then, you create a JUnit test with a rule pointing Paparazzi to your test library package. Inflate your view, call Snapshot, and we're done. Here's how this simple project structure looks. After running your test, Paparazzi will generate or update an HTML report in your build reports directory. This is HTML file, then you'll open in a browser, and here you are. You've rendered an entire Android screen without running on a device. Now, that was a simple example. Before we advance to more complicated examples, we need to take a look behind the curtain and see how this works underneath. Android Studio came out in December 2014. Lollipop was released about a month before. Before then, Eclipse was the IDE for Android development. And even from today, if you think about the history of Android development, Eclipse has accounted for half of that Android development history. And the way that you worked on Eclipse was using ADT, the Android developer tools. Maybe you used the Maven Android plugin because Gradle wasn't really a popular tool yet. And so this is like the history of Android, and here they still have some concept of a layout preview. The reason for that is Layout Lib came out around API 5. Layout Lib is a custom version of the Android View framework originally designed to run in Eclipse as part of the Android developer tools. Its goal was to provide layout rendering in Eclipse that are very close to the rendering on a device. The takeaway here is that Paparazzi is entirely powered by this Layout Lib, and so we need to dig in a little more to understand it. It's also important to know that this layout lib is still used to power the layout preview in Android Studio today, so it's been around for a while. Now you might be thinking, the Android framework jars can't be used directly in the IDE as is. They contain references to native code, say like bitmap factory. Some classes need to be overridden, for example, to replace all the drawing code and replace that with Java AWT buffered image calls. Some of the classes in Android, frustratingly, are final, and we need access to their private internal states. So anything that tries to work with the Android framework would also face that same problem. So, digging around in AOSP, you could find that there's a tool called Layout Lib Create that makes this all possible. Layout Lib Create is part of it. What it does is part of the bytecode transformation process. They apply it to the Android framework jars and use ASM bytecode transformations to stub out calls to key Android framework methods and route them to a set of fake delegate classes. So let's look at a simple example. If you look at the API 28 sources for resources.java, this is how a call to get drawable would look. and this is how it's compiled and packaged in the original Android framework jar. After processing with layoutlib create, the resources class bytecode is transformed so that the original method is renamed and suffixed with _original. Meanwhile, an additional method is generated with the original method signature as a proxy to a resources_delegate's own getDrawable method. A new class, resources_delegate, is also injected into the transform jar, providing the implementation of this delegation as a static method, which takes the original resources object as its first argument, essentially mocking Android. A quick scan of the generated layoutlib jar reveals which delegates have been provided as fakes to the original framework class, and as you can see, there are quite a bit. Everything that deals with graphics makes sense, everything with resources, typed array, asset manager, fonts, OS properties like handler and binder all have to be faked out because at the end of the day you're not running on a hardware device with these native implementations. Things like libcore also need to be faked out because of dates and times, for example, and memory mapping. It's much different on a mobile device than say how it would work on a pure JVM. Layoutlib includes a custom bridge, which serves as the entry point and sets up the environment for rendering graphics via the Android IDE plugin. The custom bridge serves as the entry point, and the rendering graphics via the IDE plugin all take place in this class bridge. After some initialization, which you'll see will determine where the location of your fonts are, and some platform build properties, and as well as a logger since you can't use the internal Android util log. Layoutlib will then serve as a bridge, providing something called a render session. And so you can just infer from the name, the render session is going to be the mocked out replacement for Canvas. You're not going to have OpenGL display lists, you're going to render to an image on your file system. And so that render session is going to be the gateway to everything that Paparazzi needs. In create session, we start by initializing the scene. In this scene, it in turn inits its superclass render action. The first thing that render action is going to do is set up display matrix. Because it's not running on a device, it still needs some idea of like a width and a height and other device configurations that you would normally have on a device but aren't provided. So that has to be set up first. Bridge context, the faked out version of context, which is crucial to Android development, has to be set up as well. So using the session params that were passed into the render session, a fake Android context is linked to a fake resource manager. You can think of it as just a map of int IDs, resource IDs, to some location on the file system. After that init is completed, the render session will take that just created bridge context and wire that to a bridge layout inflator, which indirectly uses an XML text parser. Now, if you're familiar with Android, you know this is very different from the standard Android implementation. If you unzip an APK and examine any of the res folders within it, and say introspect one of the layout files using a text-based command, you'll notice the familiar XML attributes embedded among otherwise indecipherable binary content like text appearance or text color or some of the layout attributes. Android prefers binary XML format to keep APKs smaller, and it's faster to parse as runtime. And at the end of the day, you're installing a bunch of APKs on a device, these things matter, launch speeds as well as size of APK. However, since we're bypassing much of the Android toolchain and we're not running on a physical device, and we can also bypass much of APT's conversion of the text XML to binary XML and instead just use a regular text parser. That's what this is. Okay, so returning back up into the create session method, after we initialize the scene, we inflate the scene. Makes sense. We have the context, we have the layout inflator, we have the parser. The next thing we need to do is actually inflate the scene, which will serve as the context root of your Paparazzi test scene. Something to note after this is that you can decouple view inflation from the render lifecycle. And this is a strategy that Paparazzi wholly takes advantage of. To recap, because that was a lot, first Layout Lib Create takes actual Android framework jars and converts them into a faked out version that relies on these set of delegate classes. That's crucial to being able to run outside of a device. The bridge is going to be your gateway to Layout Lib in order to interact with these inflators and contexts and then set up these render sessions. And finally, the render session is going to replace your canvas so that how you actually draw your view hierarchy will occur through the render session object. Now, the layout repo is available on AOSP, but only a smaller library declaring some of its API is published. There is no equivalent of the IMPO library to back Layout Lib. However, they do check in their pre-built jars. They have a pre-built repo with a lot of their pre-built dependencies. I'm assuming that's just how the Google backend works in order to make efficient build speed times. So with a little bit of Gradle magic and the Git plugin, which is essentially a plugin to allow Groovy to interact with Git, we can clone and publish the pre-built jar from Google to Maven Central under our own coordinates. Now, if we take a look at Paparazzi dependencies, we see there are two other dependencies that are worth touching on briefly. In Layout Lib API, the Layout Lib callback is the mechanism by which that bridge layout inflator is going to request a resource ID lookup. It sees an r.id, an r.layout, an r.drawable. That essentially is an integer, and it has to, typically, it then queries the Android framework to map this integer to some resource. And so Layout Lib is going to receive Layout Inflator's request and says, hey, I have a resource ID. Do you know what to do with this? And it will notify us also when a new view needs to be created. Traditionally, we just inflate it using reflection. Meanwhile, SDK comment defines the contract of something called a resource repository. This is the bucket that actually contains your app resources on the file system. It also provides something called a resource resolver, a class containing all the resources needed to do that rendering. It contains both the project-specific resources that either you or your transitive dependencies provide, as well as the entire Android framework resources that come bundled with Android. It also provides convenience methods to resolve resource and theme references. Now, moving back up to Paparazzi. By design, it aims to abstract a lot of this complexity away. It really tries to reduce it down to a triplet of configuration data. The package name is the same as that of your module or your project under test. Environment provides Paparazzi with a set of paths so that it can scan your project in order to assemble your screen. Following good conventions will reward you by handling all this configuration automatically. Currently, Paparazzi only knows of one type of snapshot handler, a default implementation that will write those screenshots you saw earlier to disk and generate that web page during a test run. Now that we have a basic understanding of Layout Lib and its companion libraries, let's put this all together. So the first thing that Paparazzi will do is initialize the resource pool using that Layout Lib callback. What this does is it creates a map of IDs by parsing r.jar via reflection. This is very similar to how other testing libraries like Roboelectric have always done it. Once you have that map, the next thing it's going to do is prepare a renderer object. That renderer object is Paparazzi's way of loading the framework and app resources using the underlying resource repositories and mapping those repositories to the RIDs that the layout callback just loaded via reflection. So it has to assemble this concept of a resource manager, which we take for granted via the Android framework. Context.get resources, we need to provide that. And that's what Paparazzi does to start off. It'll also create the bridge, thereby hooking into the fake layout view of the Android framework and finishing other housekeeping like loading fonts from your local directory, from your Android platforms directory, and other build properties. Next, Paparazzi is going to assemble a root content view that it's going to allow the layout parser and a default theme to be configured on. Finally, a render session will be initialized and inflated in preparation for an upcoming test run. All this happens under the hood before every test run, courtesy of Paparazzi. Inflation works as expected. It delegates to the XML block parser, calling to the layout lib callback we provided when needed, and pulling in resources as needed to assemble the view hierarchy. It adds that past view to the content root set up and prepare using the snapshot method, renders the session, takes the result, and passes it to this concept of a frame handler for processing, finally detaching the view from the content root because you may be taking multiple snapshots in a single test run. Okay, so now that we have a little working knowledge of Paparazzi internals, let's go back to kicking the tires. Earlier, I showed you this basic test example. And here again is its project structure. Let's try moving some resources into a separate module, and then sync with Gradle to update the new project structure. If we run our test again now, our launch background is gone. Why is that? The problem is that we set our environment to only look at the res folder for the project under test. Meanwhile, the project repository that's backing all this for our test won't pull up transitive resources. If everything is in one module, you're fine. However, most projects aren't like this. You add a third-party library that provides its own resources, and now you're broken again. The way that IntelliJ solved this in Layout Preview is by implementing a hierarchy of proprietary resource repositories based on the IntelliJ virtual file system, the PSI model. It crawls using Android facet objects and looks at the representation of basically the IML file in the IDE in-memory model and determines that's what my transitive projects are, and I can read the resources via that mechanism. This makes sense. Layout Preview is an IDE feature. Why wouldn't it leverage some of the IntelliJ ecosystem? But what we want is something that'll help us locate resources for test builds. Turns out Gradle can help really nicely here. By writing a plugin and hooking into the Android Gradle plugins task for our given project, we can find the directory containing all the merged resources. Then generate a properties file pointing to the merged resources directory for that project. This will then bootstrap that environment class we saw earlier with the correct res dir in our JUnit rule. But instead of pointing to project root source main res, it's going to point to your built intermediates merged variant res folder. But it's going to have everything already in it. So now instead of directly depending on Paparazzi, you'll need to apply a plugin. But it'll automatically add the Paparazzi library for you as a test dependency, which will know how to consume the property file generated by the plugin. So minimal configuration still applies. Now if we run that test again, we're back to working. It turns out this solves a majority of the problems with the layout lib, at least for what we've found so far. In Cash App, we offer Bitcoin trading. And so this is a screen from that view you might be familiar with. It leverages Robinhood. Our friends at Robinhood have this graphic library, this widget called Spark, and we leverage it. So we use it in our Bitcoin trading screen. So let's say we wanted to write a test that takes our customization of that graph and wants to render it to make sure that it works to our liking. And so taking the example a step further, we update the package name, we still inflate a layout file, we look inside that inflated layout file for a subview, just like you're familiar already in regular Android development. And then that subview has a method exposed where we can pass it a view model, it'll render that view model, and then we call Paparazzi to take a snapshot. To give you an idea, this is not just a Hello World example anymore. Like, there's actual code here that applies styles, does adapters, scrubbing, everything that is needed to configure the Spark view. And this is what we do for rendering. We were really big into this presenter view model structure, and so we pass it this view model and does conditional logic based on which type we've loaded using Kotlin sealed classes. And then finally, this is what an example, this view model, and it's not just a string and integer, but it has a set of points and something that's robust, something that you would expect a true graph to display. As a result, because we're now modularizing our app and we have multiple structures, we're going to have multiple modules that provide different parts of this test structure. So we run this test, and sure enough, this is what happens. This is what comes up, and this is all it actually wants to do. It wants to generate a certain style, it generates a set of points. It's using a third-party library, it's incorporating those resources, and so while it may not look much visually, it actually did all that work underneath. And so if you want to change your trend lines from one color to another or play with scrubbing, you can potentially do that now with Paparazzi. Let's step to a more complicated view. In Cash Card, you could also get Cash App. You can get a prepaid debit card, and we allow you to customize it by either displaying your cash tag or by there's the animation providing a set of signatures or a set of stamps. Let's see if we can test this using Paparazzi. So, similar to before, add the Paparazzi rule, updating the package structure accordingly. We inflate the view that's responsible for this card layout, and then we update the design view with a rendered preview and call Snapshot. That's easy for that first screen that we saw, this one, but then when we get to the signature screen, it's a little bit more complicated, this one right here. Can we test that as well? Let's try. To do that one requires a bit more work, as you'd imagine, but not too much more. We still take that same view. I subtly pass a different view model to render versus the other one because of the fact that, well, we're doing a bit of smoke and mirrors and playing with view visibility toggling. And then we start adding a set of points to the signature using a custom animator and providing a listener that just makes sure to know when to tie off an individual letter. So we finally end by starting the animator, and then now instead of calling Snapshot, you notice I call a different method, GIF. Paparazzi basically treats every snapshot as a frame, and if it detects that you have multiple frames, it'll stitch them together as a movie file. So it allows you to render animations as well as a view hierarchy. The way that this works is, again, using delegates. It turns out that the animation and choreographer system clocks on Android also have delegates. And so you can think of this as like testing libraries that will advance time on a scheduler and then assert on whether some conditions occurred. This is what Paparazzi is doing, but by navigating the choreographer delegate. And so we have to then provide additional attributes, what the start time and the end time is, as well as what the frames per second are. Mind you, like the higher the frames per second, the better the quality, but also it's going to take a little longer to run because it's going to take more snapshots. So now, using this, we're able to test regressions, and this is not an emulator, this is using Paparazzi. We're able to now detect and test any changes to our custom signature rendering library. To close up, this repo is currently private, but as I mentioned earlier, we're looking to open source this in a couple of weeks. We have one thing you may have noticed, and if not, I'll call it out, is that there's some clipping under the title text view on that second screen. That does not occur in the actual app, and so there are some subtleties with theming and fonts that Paparazzi, I would like to finish in Paparazzi before shipping, but we're still keeping to that 2-week timeline. Thanks, and that's it. One thing I want to mention is that we're hiring for a Cash App in New York, and so if any of this sounds interesting to you, working on Cash Card features and working on open source, please talk to me after. And also, if you have any questions on how the library works, or maybe want to play around with it in some of your custom apps, also talk to me. Feature requests and questions and feedback are always appreciated. Thank you.